What's up, guys? Welcome back to erbsclass 5-Minute Math. Today, we are here to talk about the normal distribution. Now, the normal distribution is probably something best learned through an example. So let's start with an example, right? So let's build a frequency bar graph. We're gonna build a frequency bar graph for the heights of people in this school, right? All right, so let's give me some axes. Okay, sweet. All right, so what we have here are axes, and we're going to build a frequency bar graph on these axes for heights of students in this school. So here are our axes, vertical for frequency as usual, and horizontal for our data values, of course. Height, we'll do it in inches. Okay, good. Now, this is in ascending order, so my shorter heights are going to be here, okay, of course, and my taller heights are going to be exactly right at the other end. So how many do you think, how many really short people do we have in this school? You think we have a lot of really short people? No, we probably got a couple of people in this school that are really short. And likewise, on the other end, how many people do you think we have in this school that are really tall? Like 6'10", 6'11", 7 feet? Hardly any, right? Okay, so we have a few people here that are really short. We have a few people here that are really tall. But where do you think the bulk of people's heights are going to be here? Mostly in the middle, right? There's an average height probably, and most people in the building are probably somewhere around that average height. Maybe they're taller than the average height. Maybe they're a little bit shorter than the average height. But as we talk frequencies and the number of people with these heights, as we move up in height, we will have less people at these taller heights. Likewise, as we move down in height, we will have less people at the short heights as well. Now, look at this distribution here. Looks pretty symmetric. Looks like most of my data is here centered around the middle. Now, if I were to draw a curve like this, to kind of give the pattern of the frequency bar graph, here we have what's called a bell curve. It looks kind of like a bell, and this introduces our normal distribution. So normal distribution is like a theoretical distribution. Now, heights aren't the only types of data that will fall into this type of distribution. Grades fall into this type of distribution. Machine parts and the sizes of them, they're never all exactly the same, but they always follow this type of distribution. Now, our distribution may be imperfect, so a mathematician a long time ago called Gauss came up with this normal distribution. This is like an ideal perfect world scenario. And to break it down a little bit further, the mean, median, and mode on this normal distribution perfect scenario situation is always exactly the same number, and it's always right in the middle of the distribution. Now, what this value does is it splits my distribution into halves. 50% of my data is going to be below this mean value, and 50% of my data is going to be above my mean value. This introduces symmetry, exactly right. Now, symmetry is only one aspect of this normal distribution curve, and we're going to talk about a little bit more right now. See if we can break this down a little bit further. So, as it turns out, we can break this normal distribution curve down even further. So, according to this hypothetical perfect world scenario, if your data occupies a normal distribution, there are certain things that we can say about your data. And the first thing is this. As it turns out, in a normal distribution, 68% of my data is within one standard deviation of the mean. Now let's talk about what that means. Remember, this value in the middle, this data value is our mean. That could be an X bar or a lowercase mu. This value is our mean. Now we will also be calculating a standard deviation. As you can see, I have a space on each side of this mean of one standard deviation. This is a lowercase sigma. So 68% of my data is within, as in one standard deviation above or one standard deviation below my mean value. Now it's going to make a lot more sense when we start doing some problems, but remember this 68%. And remember how this 68% takes up two sections of my normal distribution curve. Okay, so there's a 68% rule. Now, as it turns out, 68% of my data is within one standard deviation on each side. 95% of my data values will be within two standard deviations of my mean. And likewise, 99.7% of my data will fall in between three standard deviations within the mean. So if I count 3 standard deviations above my mean value and 3 standard deviations below my mean value, 99.7% of my data is in between those two values. Okay, let's talk about what that means with an example.